Hello students, this is Mr. Ezra. In the last video we talked about polynomial division using long division, this process of dividing that you kind of learned a long time ago when you were in grade school, and now we're appropriating it into polynomial division as high school students. Today we're going to focus in on some problems that may be a little more difficult than the problems we looked at in the last video, and we're also going to add an idea that you need to do with every one of these problems. So before we talk about that idea, I want you to think about this problem, 3007 divided by 26. So I want to divide 3007 by 26. How would I write that? Well, I know I'm going to put 26 outside of my division sign. And inside, I'm going to put 3 and 7. Does that look right to you? Does 3, 7 represent 3007? Hopefully you're kind of shouting at the computer, no, that's not right, Mr. Ezra. Well, we don't have a number in the hundreds place or in the tens place. So we put 0 placeholders in there to make sure that we have that place represented. So 3007 is actually 3007. Those zeros are important. When we talk about polynomial division, we're going to have to think in a similar way that all of the parts have to be represented. Like in 3007, we have to have a number in the ones place, the tens place, the hundreds place, and the thousands place for it to work. Otherwise, it's just not going to work. In polynomial division, we're also going to have to make sure that we have all the parts, or it's just not going to work. So let's look at a few problems, and we're going to start doing something that I call the countdown. For example, in number 7 here, before I actually begin to divide, I don't even care what I'm dividing. I'm going to look at the exponents, and I'm going to make sure that they're all represented, because if there are any missing when I divide, I'm going to have to put in a 0 placeholder. In this case, I have an exponent of 3, 2, 1, and 0, so I'm good. I don't have anything missing. I'm fine. I also want to do this with what I'm dividing by. Here I have an exponent of 1, x to the first. And anytime you have a constant, it's as if there was an x to the 0 there. So we can say that's an exponent of 1 and 0. So we've done the countdown and we're good. In another example today, we will see what to do when we're missing something. But in this problem, we don't. So as we work this out, it's going to be similar to the problems that we worked in the last video. So let's begin. We've got 3x plus 2 divided into 15x to the third power plus 16x squared plus x minus 2. Remember, our steps are first divide, then multiply, then subtract, then bring down, and we keep repeating that. So my first step is to divide, and I ask myself, how many times does 15x to the third divide by 3 to the x? This divide step, we only use the first term in each part, okay? Well, when you divide that, you get 5x squared. So 5x squared is the first thing. 3x goes into 15x to the third power. 5x squared times it. I line it up right here. Now, I apologize. I made a mistake when I copied this down. That should be 16x squared, so I need an x there. I'm going to add that in now. So I want those x squareds to line up when I do this. I'm now going to multiply 5x squared times 3x is 15x to the third. And 5x squared times 2 is positive 10x squared. When I subtract, I need to subtract both terms, so that means that both signs change. In this case, they both change to subtraction, to minus signs, and then I subtract down. 15x to the third power cancels out. 16x squared minus 10x squared is 6x squared. I bring down the next term, which is plus x, and I start the process all over again. This time 3x and 6x squareds are the two terms that I divide. 3x goes into 6x squared 2x times, and that's a positive 2x, so up on top here I put plus 2x, and then I multiply. 2x times 3x is positive 6x squared. 2x times 2 is positive 4x. When you subtract, both signs change to subtraction in this case. 6x squared cancels out. That is a positive 1x. Whenever there's not a number in front, it's understood to be a 1. So 1x minus 4x is negative 3x. And you bring down the minus 2. And we're at the end now, so this will be the last time that we do this process. I say, how many times does 3x go into negative 3x? And this is division. It divides to give me negative 1. Because 3 divided by 3 is 1. X divided by x is 1, so negative 1. So I put minus 1, and then I multiply that negative 1. That minus 1 I multiply by 3x, and I multiply it by 2 to get negative 3x minus 2. When I subtract, both signs are going to change. When I subtract a negative, it becomes a positive. When I subtract a negative, it becomes a positive. The 3x's cancel out. Negative 2 plus 2 cancels out. That means that I have a remainder of 0. So my final answer would be 5x squared plus 2x minus 1. All right. Example number 8. Remember, I said there's a new step that we have to focus on. We want to do our countdown. We want to look at the exponents and make sure that we're not missing anything. So my biggest exponent's a 3. I have an x squared, but I do not have an x term. I'm missing an x. I do have a constant term, so I'm not missing that one, but I am missing the x term. So when I divide here, I'm going to put 2x to the third power plus 4x squared. I'm going to put a placeholder in for that x term by putting plus 0x. This is extremely important that we go 3, 2, 1, 0, that we have all of the terms represented, and then bring down the plus 5. X minus 3 has x to the first, and 3 is a constant term, so that countdown is good, and we can simply divide by x minus 3. So I'm bringing attention to the fact that this placeholder here is super important. You've got to do your countdown and make sure there's nothing missing, and if there is a term missing, you put in a 0 placeholder. All right, this is just a regular division problem now. So how many times does x divide into 2x to the third power? And that's 2x squared times. So I line it up over the x squareds and multiply. 2x squared times x is 2x to the third power. 2x squared times negative 3 is minus 6x squared. When I subtract, both signs change, and then I add down. 4 plus 6 is 10x squared. I bring down the plus 0x so that I have two terms, a binomial, and then I divide x into 10x squared. 10x squared divided by x is positive 10x. And you'll notice that there's an x term here now so that it does line up when I put the plus 10x at the top. 10x times x is 10x squared. 10x times negative 3 is negative 30x. When I subtract, both signs change, and I combine like terms down. 0 plus 30 is positive 30x. 5 comes down, plus 5. Then ask myself, how many times does x go into 30x? And some of you are doing this in your head, aren't you? 30x divided by x is positive 30, so we put plus 30. 30 times x is 30x. 30 times negative 3 is negative 90. When we subtract, we change both sides, and then we subtract or add. 5 plus 90 is 95. That is our remainder, right? Remainder of 95. Remember, we say plus 95 over what we were dividing by, x minus 3. And we'll just circle that answer right here, like that. All right, let's move on to the next problem. Number 9 is a little different because we are dividing by a trinomial instead of a binomial, but the process is going to be exactly the same. Okay, so I start with my countdown. That's the important first step now that I have to remember. 3, 2, 1, 0. That one's good. 2, 1, 0. Both of them have all of the terms, so I don't need any placeholders, and I just set up my division problem. So I've got 6x cubed plus 23x squared plus 6x minus 35, and I will be dividing by 3x squared plus 4x minus 7. Now remember, my first step is to divide, and I only divide the first terms. I'm going to do that over here. 6x to the third power divided by 3x squared. That's the only thing that I divide. Well, 6 divided by 3 is 2, and x cubed divided by x squared is x to the first power, because 3 minus 2 is 1. Remember that rule from another class. So 2x is what we get. Remember, I like to line that up over the x term here, so that's where I'm going to put my 2x. And if you think about it this way, I am dividing by 3 terms, so I'm going to start my answer on my third term. It should line up where it's above the same degree part, same degree term. I multiply 2x times all 3 of these terms over here. So 2x times 3x squared is 6x to the third, because 2 times 3 is 6, and x times x squared is x to the third. 2x times 4x is positive 8x squared, and 2x times negative 7 is minus 14x. When I subtract, all of the signs are going to change to their opposite, because I'm subtracting 6x cubed, I'm subtracting 8x squared, I'm subtracting negative 14x. So those change to minus, minus, and plus, and then I combine those like terms down. Now, the first one should always cancel out. 23 minus 18, I'm sorry, I said that wrong. 23x squared minus 8x squared is 15x squared. 6x plus 14x is positive 20x, and we bring down the last term here, minus 35, and we do the process one more time. Focusing on the first terms, how many times does 3x squared go into 15x squared? Well, the x squareds are going to cancel out, and 15 divided by 3 is 5. So I put plus 5. I multiply 5 times all 3 terms on the left. 5 times 3x squared is 15x squared. 5 times 4x is positive 20x. 5 times negative 7 is negative 35. When I subtract, all of the signs change. So minus 15x squared minus 20x plus 35. And when that happens, all 3 of these parts cancel out, which means I have no remainder. My final answer is 2x plus 5, no remainder. For number 10, I encourage you to pause the video, try this problem on your own if you aren't already doing that with these guys, and see if you can get it right, and then start the video back up and check your answer. All right, so we're going to start with our countdown. 3, 2, 1, 0. All terms are represented. I do not need any placeholders. 2, 1, 0. All terms are represented here. I don't need any placeholders, so I can go ahead and proceed to my division. I'm going to divide negative 7x squared plus 5x plus 2 into negative 28x to the third minus 15x squared plus 33x plus 5. Remember, we focus only on the first terms when we divide. Negative 28x to the third power divided by negative 7x squared. Negative divided by negative is positive. 28 divided by 7 is 4. x to the third divided by x squared is x. So we divide negative 28x to the third by negative 7x squared to get 4x. I line it up over the appropriate spot here, the third term in, which is right here. And then I multiply 4x times all three of these terms over here. 4x times negative 7x squared is negative 28x to the third power. 4x times 5x is positive 20x squared. 4 times 5 is 20, x times x is x squared. 4x times 2 is positive 8x. When I subtract, all the signs change, so that's going to become plus 28x to the third minus 20x squared minus 8x. And then I combine down. First one cancels out. Negative 15 minus 20 gives me negative 35, and that's going to be x squared. 33 minus 8 is positive 25, and the x is going to come down. And then we bring down the plus 5. So we divided, multiplied, subtracted, brought down. We start the process all over again. This time, how many times does negative 7x squared go into negative 35x squared? The x squareds cancel out, the negatives cancel out. 35 divided by 7 is positive 5. So I'm going to put plus 5, and then I'm going to multiply by everything over here. 5 times negative 7x squared is negative 35x squared. 5 times 5x is positive 25x. 5 times 2 is positive 10. All right, when I subtract, all of my signs change to their opposites, because I'm subtracting this whole polynomial. I'm subtracting all the parts of it. When I combine things down, 25x minus 25x cancels out, but 5 minus 10 doesn't cancel out. I'm left with minus 5 or negative 5. Now, I could put plus negative 5 over this whole polynomial here, but instead of plus a negative, I'm just going to put minus 5 over, and then this whole polynomial goes in the denominator, negative 7x squared plus 5x plus 2. And for today, we're going to leave it like that. Just leave that denominator the way that it is. So our answer is 4x plus 5 minus 5 over negative 7x squared plus 5x plus 2. Before you get to class, I would like for you to try number 11. We've got a very large problem, but you're going to do the same process that we just did. I'd like you to try to divide 8x to the 5th plus 10x to the 4th minus 36x cubed plus 34x squared plus 32x minus 54 by 2x squared plus 4x minus 6. Follow the steps, follow the procedures, do your best, and we'll talk about this problem in class. So that's it. It is important, the new thing today is that you do your countdown before you begin. If there's anything missing, you've got to put a 0 placeholder in for that part. If you have any questions as you're working through your problem set, make sure to ask them, and I will see you in class.